All right, so we are going to start with question number 28 where we left off today in class. So in order to do this one, when we are doing these ones that say elementary exponential equation, we are wanting to get the same base value. So in this instance, we have a base of 5, which is a prime number. So what we want to know in this particular one is, can we rewrite this 25 as 5 to some power? And hopefully you're telling me 5 squared. So this would be 5 to the 3x minus 7 over 1 over 5 squared. And then remember what we're going to do here is, because we don't want a fraction, we're going to take this guy and we're going to move him up. But remember, when we do that, that means that this exponent has to change signs. So it's going to become a negative 2. So I'm going to bring it up over here. So we're going to have 5 to the 3x minus 7 equals 5 to the negative 2. And then the good thing about these elementary exponential equations is, once we get the same base, we get to take away those bases, and then we just take our exponents and set them equal to each other. So we have 3x minus 7 equals negative 2, and we solve this problem, so we're going to add 7 to both sides. 3x is going to be equal to 5, and then we're going to divide by 3 on both sides, and there is our answer. So x is equal to 5/3. Question number 29 is pretty much the same thing as 28, just a little bit bigger numbers. And if you're ever unsure when you're looking at something like this with like 64 or 32, and you're like, let's see what we can do with that, take your 32. I always like to start with my smaller number. And I come over here and I break 32 apart, and 32 is 8 times 4. 8 is 2 times 4. 4 is 2 times 2. Again, 4 is 2 times 2. So if you look at this, we have 1, 2, 3, 4, 5 2's. So this is 2 to the 5th power. So we can rewrite this guy as 2 to the 5th power, still raised to the negative x plus 4. So then the question becomes, can we do the same thing with 64? So again, you have a couple options. You could just work through it. We know 2 to the 5th is 32, so it's got to be, since 64 is bigger, we've got to go up. So you could go over there and say, well, what is 2 to the 6th power? And if I pull out my calculator and do 2 to the 6th power, I get 64, so there's my answer. Or you could break 64 down just like we did with the 32, and you'll see that it's 6 2's that multiply together. So we're going to rewrite this one as 2 to the 6th power raised to the x minus 3, and these are equal to each other. So remember, what we're going to do here with this is we're going to multiply or distribute that out. So we're going to end up with 2 to the 6x minus 18. And then on the other side, we have 2 to the negative 5x plus 20. Remember, when you distribute it, it doesn't just go to the x, it goes to the numbers while you're doing a full distribution. And then just like the previous problem, once we get the 2's the same, we can cross those out. And we're going to take this guy and set it equal to each other. So now we have 6x minus 18 is equal to negative 5x plus 20. I like to always move my x's first, so I'm going to go ahead and add that 5x to both sides. So that is going to give us 11x minus 18 equal to 20. And then we're going to add 18 to both sides. So that's going to give us 11x equal to 38. And then the last step we'll do is divide by 11. That's going to get our answer of x is equal to 38 over 11. Doesn't reduce, doesn't divide out, so we're just going to leave it in that fraction form of 38 over 11. All right, so the next one we have is out of section 7.2. So these are kind of our word problems. We're going to start here. It says Amanda invests $5,400 in a new savings account that earns her 5.8% annual interest compounded monthly. What is the value of her investment after 5 years? The key word here is this compounded monthly. It tells us what formula to use, and that is going to be the A equals P times 1 plus R over N raised to the NT. And as we go through this problem, we're going to pick out our pieces. So we're going to start here with the 5,400. That's going to be our principal, or our P. Our 5.8% is going to be our R. And remember, we're going to make that a decimal. So it's going to be 0.058. Our N is going to be this monthly right here. So our N is going to equal 12, since there are 12 months in a year. And the last thing we have is our time. That's going to be 5 years. So T is equal to 5. And remember, all we have to do is plug these 4 values in and then use our calculator to find our answer. So A is equal to 5,400, parentheses 1 plus 0.058 divided by 12 raised to the 12 times 5. And again, remember, once you get it into that formula, then it's just a matter of pulling out our calculator here and sticking this into our calculator. So 5,400, parentheses, 1 plus, go grab my fraction here, 0.058 over 12, end our parentheses, go grab our exponent, and we have 12 times 5. And we get our answer of $7,211.67. Okay, so really on that problem, it's more about knowing the formula that you need to use and being able to pick out the 4 values that you have to have in order to do that. So number 31 is a 3-part problem. The first part is we want to find the A value for the half-life of radium 223, I can say that. So first of all, if you look up here in the instructions, it tells us that the half-life of radium is approximately 11.43 days. Okay, so what we're going to do is on this first step, we're just going to pick a beginning amount. And that is going to be our A sub naught. I'm just going to do 100 grams just because it's easy. Then after 11.43 days, we should have half that amount left. So our A sub T is going to equal 50 grams. So now we have basically the three things that we need to plug into this formula in order for us to find that 1A value. So I'm going to come over here to the side and do this. So we have our 50 grams, because that's what we're going to have after our 11.43 days, is equal to 100 A to the 11.43. Okay, again, the only thing we didn't know was that A value, so that's why we don't have a value for that. So here we're going to divide by 100 on both sides, getting rid of the number in front first. So 50 divided by 100 is 1/2, or 0.5, is equal to A to the 11.43. And what we're going to do to get rid of that 11.43 is we are going to raise this to the reciprocal of that thing, which is 1 over 11.43. I know it's kind of hard to read there when it's inside that step, but we're going to do the same thing over here. We're going to raise this to 1 over 11.43. So again, we're going to take that to our calculator to figure out what that is. So in our calculator, I'm going to go ahead and do my parentheses and do 0.5. And I'm going to go grab my exponent and make it a fraction. So I have 1 over 11.43. And we're going to round this to the 6th decimal place. So we're going to have 0.941159 is equal to our A, and that's going to be our answer right here, 0.941159. And again, when you start this problem out, this beginning amount here can really be anything you want it to be. I usually just choose 100, mainly because it's easier to work with. But you could do 10, you could do 5, you can do any number you want. The only deal is whatever number you do there, you're going to do half of it to get the after part, after the half-life. So if you had 10, you would have done 5. If you'd have had 5, it would have been 2.5. You get my picture. You're just taking half of it to get that second part of the equation. All right, so now it says how much of an 8-gram sample would you have after 3 days? So now they're actually defining our beginning amount, and this is our A sub naught. So the first thing I need to do is write my equation. So I have A at T is equal to 8 grams times, now remember here, up here is where I found my A, so I'm going to use that for my A of 0.941159 to the T power. Okay, we're actually going to use this equation for both steps 2 and 3. So on this first one, we're going to find A at 3. So this is going to be 8 times 0.941159 to the third power. And again, we're definitely going to have to use our calculator to figure this one out, and we're going to round to 3 decimal places when we do. So 8 times 0.941159, go grab my exponent and raise it to the third power, and we get that after 3 days, we would have left 6.69, oops, I've left off a 6, 6.669 grams. And this would be our answer for step 2. So for step 3, notice that we're using the same amount of initial grams here. So it's still doing our 8 grams, so A sub naught is still the same. But this time we want to know after 9 days. So again, we're still using that same formula we just came up with. We're just doing A at 9 is equal to 8 times 0.941159 to the 9th power. And again, we're going to use our calculator to do this. And by the way, since I'm going 9 days, since the last one was 3 days and this one's 9 days, my answer should be smaller than this 6.669. Okay, so always remember that when you're doing these problems, that if I'm going more days, then my amount left over should get smaller. And if closer I get to the half-life, in this case 11.43 days, the closer and closer my answer should be to half of whatever my initial amount is. So again, we're going to do 8 times point, oops, not zero on the wrong spot, 941159. Again, grab my exponent, raise it to the 9th power, press enter. And we're rounding to 3 decimal places, so this would be 4.635 grams, and this would be our answer. So you can see 9 is fairly close to 11 days, so my resulting answer is fairly close to half of what we initially had, the 8 grams. Okay, so the next couple of questions are going to be out of 7.3. We're going to use our log to exponent rule here. So if you'll remember, we had our rule that said if we had log base b of n equal to p, we could rewrite that as the base to the power equal to n. So remember, when you're doing this, you do the base, you go across to get your power, you go back across to get the equal to. So if we look at our problem, our base is 2. We're going to go across to get our power. So that means we have 2 to the 6th power. And then we're going to come back across to the inside here to get what it's equal to. So 2x minus 4. Now 2 to the 6th power, that is going to give us 64. So 64 equals 2x minus 4. Here we're going to add 4 to both sides. So 68 equals 2x. And last we're going to divide by 2 on both sides. And we get that 34 is equal to x. And that's going to be our answer for this one. Okay, we're actually going to use the exact same rule for number 33, except this time because we're working with an ln. Remember that the base here is an e. So we're going to have e, I'm going to go across to get the power. So we're going to have e to the 4th power. And then we're going to come back across to get what it's equal to. So this is equal to 5x plus 12. And again, you can go into your calculator and figure out what e to the 4th is and work your way through. I personally like to wait until the very end and put it in the calculator at the end of the problem. So what we're going to do here is subtract that 12 from both sides. So we're going to have e to the 4th minus 12 equal to 5x. I'm going to pull this up over here so I have some room. So we have e to the 4th power minus 12 equal to 5x. We're going to solve for x, so we need to divide by 5. Remember, we're going to divide this whole thing by 5. And what we're going to do is we're going to take that e to the 4th minus 12 over 5, and we're going to put it in our calculator. So you should have an e to the x button, so you get your exponent there. So I have e to the 4th. Going to come out of that exponent, subtract 12. Go ahead and press enter. So that's the top of my fraction. And now I'm going to divide that by 5. And we're going to round that to 2 decimal places. So we get 8.52 is equal to x. And this is our answer for that problem. So again, we're using the same process that we did for the previous problem, except instead of getting a nice number like 64, we got this e to the 4th thing. But again, you're just going to use your calculator to figure out what that particular e to the 4th is. And I like to do it after, so I just do it all at once instead of doing it as I go through the problem. All right, so the next one, we are using our properties of logs. In this case, we're going to expand, but I want to go ahead and write out our properties over here. So let's talk about expansion first. So remember, when we expand, we do a specific order. So we're going to start with our division log. So the log base b of x divided by y gets to break apart as the log base b of x minus the log base b of y. So remember, my division breaks apart as my subtraction. Then the second thing I want to look for is multiplication. So my log base b of x times y is equal to the log base b of x plus the log base b of y. So my multiplication breaks apart with addition. And then the last one is exponents. If I have the log base b of x to the a, that a can come out in front and be the a of log base b of x. And I'm using logs here, but remember that these are the same rules for ln because ln is just a log base e. All right, so if we look at this particular problem, the first thing we're going to want to split up is that division. So we're going to have the ln of 8x squared minus the ln of y to the 8th. Remember, we always want to make sure we do them in order. So the top goes first, the bottom goes second. So separate it with a subtraction. They're both getting their own ln. So the next thing we're going to do is we're going to break up that multiplication right there between the 8 and the x squared. So we're going to say this is the ln of 8 plus the ln of x squared minus the ln of y to the 8th. And then the last thing we're going to do is we're going to take these exponents here and here, and we're going to pull it out in front of that one ln. So now we have the ln of 8 plus 2 ln of x minus 8 ln of y. And this is our answer for this particular problem. Now in the next one, we're still using those same properties of logs, but this time we want to condense. So in the previous one we expanded, in this one we're condensing. And remember, the cool thing about condensing is all we have to do is do the opposite. So if we do condense, then we go 1, 2, and 3. So we go the opposite direction, and we start with our exponent, then do our addition, which goes back together as multiplication, finally doing our division. So in that case, that means that this 3 out in front is going to come up here as an exponent, as well as this 9 right here. So we're still going to have the ln of 11, but this is going to be the ln of x cubed minus the ln of y to the 9th. And then we're going to bring back our addition to multiplication. So this is going to be the ln of 11x cubed minus the ln of y to the 9th. And then the last thing we're going to do here is that subtraction, which is going to come back together as division. So we're going to have the ln, remember always the first one is on the top, so 11x cubed over y to the 9th. And that would be our answer for that one. And really, if you look at these two problems, they're literally the exact opposite of each other. As far as the way the answers, you can notice that my question on 35 looks like the answer on 34 and vice versa. So you can kind of see that, how they are very much related to each other. So the next couple problems are all from section 7.5. We're going to be solving the logarithms. Remember, the first thing we want to do with any of these guys is always bring it back together. Since this is a subtraction, it's going to come back together as division. So this will be the log base 4 of x minus 4 over x minus 1 equal to 1. Now, since there's not a log on both sides of this equation, we're going to do what we did for those problems in 7.3. We're going to do our conversion. So we're going to take our base, we're going to go across to get our exponent, and we're going to go back across to get what it's equal to. So we have 4 to the first power is equal to x minus 4 over x minus 1. So now what we need to do is get rid of that denominator. I don't really need that 1 on the 4 either, so we're just going to multiply over here by x minus 1, multiply over here by x minus 1. And that means that we're going to distribute this 4. Okay, so we have 4x minus 4 equals x minus 4. I'm going to go ahead and move my x first. So I'm going to subtract 3. Oops, not 3. I don't know where that came from. Here we go. Let's try that again. I'm going to subtract x from both sides. There's where the 3 came from. So I get 3x minus 4 equals negative 4. So then if I add 4 to both sides, 3x equals 0 here. And then coming in and dividing both sides by 3. And we get x is equal to 0. Now remember, on these log problems, you always have to come back up here to the top and plug in the 0 and ask yourself if 0 minus 4, that's going to give us negative 4. And we can't take the log of a negative number, so we can't use this as an answer. And for this one, our answer is actually going to be no solution. So remember, every time we get an answer, we have to make sure it keeps the inside of our logs. So these guys right here keeps those insides positive. And since this came out to be a negative 4, it's not a positive value, we can't use that 0. So in this case, since I only had the one option of an answer, I don't have a solution. All right, so number 37, kind of similar here, except this time we have a plus here between them, which means we're going to multiply these logs together. So we're going to get the log base 5 of x minus 4 times x plus 1 equals the log base 5 of x minus 2. And the other good thing about this particular problem versus the last one we did is it's kind of like our bases that we had in those 7.1. As long as we have the exact same log on both sides, we can actually just cancel those logs out. And we just take the inside of these guys and set them equal to each other. So that means that we're going to have x minus 4 times x plus 1 equal to x minus 2. So we're going to FOIL, and this is going to give us x squared plus 1x minus 4x minus 4 equal to x minus 2. Since we have an x squared, we're going to move the x and the negative 2 over. So we're going to subtract x, add 2, and in this case, our x's actually cancel each other out on both sides. So what we end up having, let me bring this up here because I'm running out of room, is we have x squared minus 4x minus 2 equal to 0. And we're going to use our quadratic formula. So a is 1, b is negative 4, c is negative 2. So using our quadratic formula, we have x equal to opposite b plus or minus the square root of negative 4 squared minus 4 times 1 times negative 2. So x equals, oops, I forgot my bottom, over 2 times 1. So x equals 4 plus or minus the square root of 16 plus 8 over 2. We're going to keep going with this. So 4 plus or minus the square root of 24 over 2. And remember, for these particular problems, because I do need to go back and check and make sure they work, I want to go to my calculator and get these into decimals. We're going to round to 4 decimal places. So we're going to do our plus and our minus in our calculator. So I'm going to bring my calculator out again. I've got 4 plus the square root of 24. I'm going to go ahead and press enter and then divide that by 2. Don't forget to do that division. And if we round that to 4 decimal places, we get one possible answer of 4.4495. And now we're going to do the opposite. We're going to do 4 minus our square root of 24. And we get that decimal there. We divide it by 2. And we get negative 0.4495. But remember, we have to check and make sure both of those answers make our insides of our logs positive. So if I were to put 4.4495 minus 4, that's a positive number. If I were to do 4.4495 plus 1, that is also a positive number. And if I were to do 4.4495 minus 2, that is also positive. So this answer is completely acceptable. That is going to be one of our answers, 4.4495. But if I did the same thing with the negative one, and we did the negative 0.4495 minus 4, that's going to be a minus answer. So this is not going to work for us, and our only answer is going to be that positive one. So remember, whenever we're working with logs, we always have to go back and make sure they keep our logs positive, whatever number we put in. All right, so number 38, still in the same section. We're going to start this, I'm going to start this problem off by dividing out that 3 from both sides. So we get rid of that 3 there. Oops, I didn't mean to do it in green, but that's okay. So we get e to the 5x plus 15 equals 147 divided by 3, which is 49. Now, because we don't want this ln or this e here, we're going to take the ln of both sides. So we're going to do the ln of e to the 5x plus 15 equals the ln of 49. And what's going to happen, and we kind of skip over this a lot, what's going to happen is that is going to come out here in front of our ln, so it's going to be a whole, it's going to be out in front, and then the ln of e is actually going to cancel out because it's just going to be 1. So what we end up having is 5x plus 15 equals the ln of 49, and now we're just solving for x. It's a linear equation. It just has a funky answer over here with the ln of 49. So we're going to subtract 15. I'm going to put that on the end there. So 5x is equal to the ln of 49 minus 15. And then we're going to divide by 5. So x equals, and again, we're going to put that in our calculator, round it to 2 decimal places. So we're going to do the ln of 49, end our parentheses, go ahead and we can subtract that 15. We'll do the top first, and then divide that by 5. And we get our answer being negative 2.22. And since we're only rounding to 2 decimal places, that's going to be our answer. Okay. So on this number 39, there's a couple different ways you can do this. I like to do this using our conversion rule. So we're going to convert this back into logs. So remember, this is going to be my base. I'm going to go across to get the inside. And then we're going to go back across. That's going to be our equal to. So we're going to have the log base 7 of 981 is equal to x plus 5. And then the only thing we need to do to solve that is we're just going to subtract 5 from both sides. So we have the log base 7 of 981 minus 5 equals 0. Oops, sorry about that, guys. Let me get back to where we can do this problem. There we go. So now we just need, not equal to 0. Sorry about that. How about equal to x? So now let's put this in our calculator. If you don't have the log base function, you're going to use our change of base. So we're going to do the log of the top, or the log of the inside, 981. And we're going to divide that by the log of the base, which is 7. And we're going to press enter, so we get that. And then we can take that and subtract the 5. And we end up getting this being 1.46 is equal to x. Oops, negative 1.46 is equal to x. Okay. I'm going to pause it right now, and then I'm going to do a second video finishing off the rest of the problems that are all from chapter 8.